So we're going to continue our max-min problems, and we are going to start some triangles. Triangles are a little harder than rectangles, and we'll do one triangle and a rectangle for today. So 5-4C, what is the largest possible area for a right triangle whose hypotenuse is 7 centimeters long, and what are the dimensions? Well, first we're going to draw a right triangle, and the hypotenuse is 7. Now, I don't know what either one of these sides is, so I'm going to call them X and Y. All right, so let's go with what we know. We're trying to maximize the area, and we know that the area of this triangle is 1/2 base times height, so 1/2 XY. We also know from the Pythagorean theorem that x squared plus y squared is equal to 49. So we need to take the derivative of this capital A here, this one, and the way we're going to do that is we need to solve for y in our Pythagorean theorem equation. So let's go ahead and solve for y. We'll subtract the x squared over to the other side to get 49 minus x squared. So that would make y equal to plus and minus, but we're just going to go with the positive because y is a side of a triangle. We want the maximum area, so there it is. All right, so we're going to go back and plug this in. So we have 1/2 x times 49 minus x squared to the 1/2. So square root. I just rewrote it in its exponential form. So let's go ahead. So that was just the setup. Now let's take the derivative. So a prime is equal to, and the derivative we need to use the product rule because we have one function and we have another function. And not only are we going to use the product rule, we're going to use the quotient rule too. So here we go. We're going to go a, which is 1/2 x, times b prime. B prime is this part right here. So to take the derivative of that, we're going to bring the 1/2 down and multiply, leaving the inside alone and subtracting 1 from 1/2 to get negative 1/2. Then, don't forget chain rule. We need to take the derivative of the inner function. So the derivative of 49 is 0, and the derivative of negative x squared is negative 2x. So that was just a b prime, and then it's going to be plus b, which I'll just write as 49 minus x squared, square root, b times a prime, and a prime is the derivative of 1/2 x, which is just 1/2. All right, so that's the derivative. Let's clean this up a little bit. Over here, I have a 1/2 x times a 1/2 times a negative 2x. So what that does is that will give me a negative, one of the 2's will reduce with a 1/2, a negative x squared over 2. And then I also have times the square root of negative, or the negative square roots, or to the negative 1/2. So that's going to be on the bottom. Square root of 49 minus x squared. Plus the square root of 49 minus x squared over 2. Whew. All right. Now, this is the algebra is the hard part, right? Now we need to set that equal to 0 and solve. And if we set it equal to 0, we can go ahead and take this negative part and just add it over to the other side to give us x squared over 2 rad 49 minus x squared, and that's going to equal rad 49 minus x squared over 2. All right, so now we're solving this equation right here. So let's cross multiply, and when I do that, I get 2x squared equals, and when I cross multiply this part here, I get 2 times rad 49 minus x squared times rad 49 minus x squared, which would be 49 minus x squared. Perfect. All right, so let's divide both sides by 2, and now I have x squared equals 49 minus x squared. We're going to add x squared to the other side and get 2x squared equals 49. We're going to divide by 2 and then take the square root of our answer, and we get, let's see, the square root of 24.5 is 4.95. So x is about 4.95, and then we need to figure out what they're asking for. So what are the dimensions? What is the largest possible area, and what are the dimensions? So we know that the dimensions are x is 4.95, y is the square root of 49 minus x squared, 4.9 squared. And the funny thing happens where y ends up being exactly the same thing. So we have x is 49.5, y is 4.95, and then the area would be 1/2 times those things. Let's do the answer squared times 1/2, and so the area is 12.25. There you go. Very complicated triangles. All right, the second one, number 2, we need to find a rectangle whose base is on the x-axis, upper 2 vertices of the parabola. Okay, well, I'm going to start by factoring an x out. I know this is a parabola, but I want to see where the zeros are. And the zeros happen at 0 and 6. So this is what my parabola looks like. Goes like this, goes through the origin, has 0 at 0 and at 6. And I want to maximize the area of the rectangle inscribed in that parabola. So there's my rectangle. All right, so start by naming from the origin out to your rectangle. You're going to label that x. Now it's going to be an x on this side. And so the base of this is going to be the entire thing minus those little pieces. So we'll say that the base is 6 minus 2x. All right, and then the height is however tall h is. Well, this is where x is, exactly x. This is the point xy, and it's on this parabola. And on the parabola, when the point is xy, that means that y is 6x minus x squared, and that would be the height. So now we have our height, we have our base, and we can come up with the area function. So the area of a rectangle is the base times the height, or length times width, whatever you want to call it. And now we need to take the derivative to maximize that. Well, you could do product rule, but let's go ahead and FOIL it out and then take the derivative after we FOIL our equation, our binomials. All right, so we get 6 times 6x is 36x. Outside is negative 6x squared. Inside is negative 12x squared. And then my last term is positive 2x cubed. So let's clean that up. We've got 2x cubed. I'm going to rewrite it. Got a negative and a negative, give me negative 18x squared plus 36x. Okay, so now I'm ready to take the derivative and set it equal to 0. So a prime is equal to 6x squared minus 36x plus 36. Set that equal to 0 and solve. I can factor a 6 out. X squared minus 6x plus 6 equals 0. Okay, now right here, this is, you can try and factor it. It's actually not factorable, which is a bummer. I like to make them factorable, so they're really nice and easy to do. But a lot of people have a program, quadratic formula program. That's fine because we don't need it to be in, radical form, so that actually works. I went ahead and just graphed y equals x squared minus 6x plus 6 on my calculator as y1 and y2 was 0. And I just found their intersection. And there's 2 intersections, as you can see. And then when you do the quadratic formula, you'll get 2 intersections. And I get that x is approximately 1.27. The other one is going to be a larger x, which would end up making the base negative, and you don't want the base to be negative. So there's our x. That's not the answer, though. It says, what is the largest area and what are the dimensions? So we need to go back to the base, and the base was 6 minus 2 times x. So we'll go 6 minus 2 times 1.27. You can round to 2 decimal places is fine. And we get 3.46 as the base. And the height of this thing is going to be 6 times 1.27 minus 1.27 squared. And I get that that's about 6.01 or 6. Is that right? Did I do it right? Maybe. 6x and then minus 1.27 squared. Yeah. 6.01, if you want to say that. Okay, so I have the base and I have the height, so that's the dimension. And then the area would just be to take those two numbers and multiply them together, base times height. So the area would be about 20.78. And I don't believe any of this is in units at all. Nope. So that would be your answer. All right, try the max min problems in your homework. I think I assigned 4 of them.